There we go. So systems of linear equations with two variables. You also have with three variables, but we're going to do that after this. Okay, so your first step is you want to understand the question. A lot of times I'd like to draw a little graph or bracket or a picture or something to help me understand what it is I'm trying to answer. Understand the problem. Reading it multiple times. And drawing a picture. Sometimes helps. Uh-oh. Okay. So your second step is you want to choose two variables to equal your unknown. So whatever it is they're asking you for, say, okay, if they're asking this, I'm going to make this x. And this what I'm asking for, I don't know what it is, so I'm going to make this y. This way you just have your two variables there. Then you want to translate it. Into two equations. Okay, so once you pick your variables and you kind of create your equations, you can now solve for them. Okay, so then you just want to solve the system once you figure out what it is. And that was just explained using everything we did in the last class. Okay, so just a quick example. I'll move that up a little bit. Okay, and we'll make this one pretty, pretty straightforward. So let's say if you wanted to find two numbers whose sum, remember sum is just a fancy way to say add, is 37, and whose difference, remember that's just a fancy way to say subtract, is 21. Move that up a little bit. All right. Okay. Now the first step, you kind of understand it, but if you wanted to draw a picture, it would look something like this. At least for me, this is how I would make it. Where you know some number. Oops, should have made that bigger. Plus some number. Or you can say another number. Equals 21. Oh, should have made that 37. Doesn't matter. Nope, should have been 37 for the sum. And 21 for the difference. Okay, and we have that same number. I'll just use the pound sign minus some number equals 21. Bless you. Okay. So what we can do is we can make the first unknown number equal x. X equals first unknown number. Okay. And we can let y equals the second unknown number. That makes sense so far? Okay. Okay. So now we just replace what's in here with our variables. So we have x plus y equals 37. And x minus y equals 21. Okay. So now this is just our third step where we'll solve our system. So you know when you're solving the system, you want to have the coefficients have different signs. So one's positive, one's negative. So as soon as we add those together, the y is going to disappear. Then we plug those in and we solve for our x. Okay, so we can go ahead and just add those together now. Okay, so x plus x is 2x. Okay, positive y plus negative y. Y minus y is 0, so those cancel out exactly like we want it. I'll make that a little clearer. Okay, and 37 plus 21, 7 plus 1 is 8, 3 plus 2 is 5, is 58. Okay, so we know that, should have probably started this on a new page, but may be able to squeeze it all in here. That 2x equals 58, divide both sides by 2, we get x equals 29. Okay, so now we just plug that into either one of these equations and solve for y. Okay, so we have kind of, I think next time I'll make sure to start on a new page. Okay, so if we know that x minus y is 21, we plug in that for 29. 29 minus y, probably should have used the plus, but well. It's 21. Subtract 29 from both sides. So we have negative y, sorry about the cramming there, I'll make sure not to do that again, is equal to negative 8, or y equals 8. Okay, so you have your, all you have to do is double check. 29 plus 8 is 37, 29 minus 8 is 21. So you know you have the right one. Okay, any questions on that one? All right. Like I said, you can do it multiple ways. This is just the method that I found kind of simplifies it a little bit because the questions can get a little bit complicated. All right, let me do this over here. Okay, so let's start with another example. Actually, this would just be a simple interest problem. Okay, so we know the formula for simple interest. If you forgot it, we can go over it right now. Is equal to the principal, which is your starting amount, or the amount invested, times the rate, interest rate, where that's going to be in percents, but you want to convert it to decimals. Times the time. And the time is always in years. Okay. So the shortcut to that is interest equals principal times rate times time. So that's your simple interest formula. Oops, sorry, let me lower that. Okay. So if we have a problem that requires simple interest, we'll just use this formula. Okay, so let's say Tom invested part of his $20,000 inheritance. Forgot my eye. In a mutual fund. That pays 7% simple interest once a year. And the rest in a certificate of deposit that pays 9% once a year. Okay, so at the end of 1 year, the investments earned $1,550. Okay, so you want to find how much he invested into both of those interest rates. Let me move that up a little bit. Here we go. Okay, so if we want to know how much he invested into each one of those, one pays 7%, one pays 9%. We want to see how much he invested. Okay, so if we look at this, we know that the amount of interest he earned was $1,550. But we want to know, okay, how much did he earn from each one? So we can just draw our picture. So we know that the interest earned at 7%, which we know is 0.07 since we're going to convert it anyway, plus the interest earned on his investment at 9%, so which we know our 9% is just 0.09 once we plug it into our formula, is going to equal $1,550, because that was how much total he made from them. Okay, so that setup makes sense? All right. Okay, so all we have to do is let x equals 1 and y equal the other. Okay, so we'll let x equal the amount invested at 7%, and we'll let y equal the amount invested 9%. Okay, so now we just have to figure out exactly which is which. Okay, so we know just from our graph there that 7% of whatever it is he invested plus 9%, we can see, 0.09, sorry about that. Forgot my point, I'll rewrite that. 0.07 x plus 0.09 y equals our $1,550. Oh, sure. Sorry about that. Okay. But we also know he invested a total of $20,000, which means that whatever he invested at 7% plus whatever he invested at 9% will total $20,000. So that gives us our second equation. Okay. Now, I don't know about you, but me personally, I don't like having to multiply decimals and all that and add and everything. So I would probably solve this one using substitution. Only because all you have to do is subtract x from both sides and you solve for y and you can just plug it in. It just will make it a little easier to me. But if you wanted to do it using the elimination method, you could do that also. You just have to multiply by either negative 0.7 or negative 0.9 down here, add them together and do all of that, which would work. It just would seem a little bit longer to me. Okay, so if we just go ahead and make this equal, I'm running out of room already. Yep. Okay, so we have 0.07x plus, separate that a little bit, 0.09y equals 1,550. We subtract x from both sides, we have y equals 20,000 minus x. Which means all we have to do is plug this in here, and we can just solve for x. We'll make it a little bit easier. I'll leave that up, and I'll continue that on the next page. All right. Okay. Oh, would help if I looked at where I left off. Let me just go ahead and write where we left off. Plus 0.09y, 1,550, y equals 20,000 minus x. There we go. Okay, so now if we just plug that into this one, that would give us 0.07x plus 0.09, and instead of y, we just plug in that. 20,000 minus x equals 1,550. Okay, so now all you have to do here is solve for x, since that's the only variable up there. So we just go ahead and distribute that 0.09. So 0.07x plus 0.09 times 20,000 is 1,800. Minus 0.09 times negative x is 0.09x equals 1,550. So make sure I didn't go up too far. There we go. Okay, so if we subtract 1,800, well, actually we can combine these two first. 0.07x and negative 0.09x is negative 0.02. So you have 1,800 minus 0.02x equals 1,550. Okay, so if we subtract 1,800 from both sides, we end up with negative 0.02x equals negative 250. Okay, divide both sides by negative 0.02. We end up with x equals 12,500. Okay, so that's the amount he invested at 7% interest. Okay, any questions on that so far? Okay, so now all we have to do is get our x value, plug it up here, and solve for our y. So since y, make sure it's up far enough, is equal to 20,000 minus x, we know that y is equal to 20,000 minus 12,500. Okay. So that means y is equal to 7,500. And that's the amount invested at 9%. All right, so any questions on that one? Yes?
So I got a question. How did you get negative 450?
Oh, I subtract 1,800 from both sides. So these two, when they cancel out, on the right side, you end up with this. Okay. Any questions on that one? All right. Okay, let's see, 3. All right. Now the distance problems, they're a little bit tricky, and those are the ones that I found that the pictures actually help a lot. Some of them you can do them without the pictures, but the pictures help a lot. Okay. So start with our lower that. There we go. Distance problems. Okay. And most of the distance problems revolve around the formula. Distance equals the rate times the time. Or usually you'll see D equals R times T. Okay, so that's the formula we're going to use for most of our distance problems, or really all of our distance problems. Okay, so let's say, for example, 2 cars leave Richmond. At the same time. Okay, the cars travel in opposite directions. Okay, so one travels north at 56 miles per hour. And one travels south at 47 miles per hour. Okay. So when will those two cars be 206 miles apart? Okay. So really, this is, like I said, the biggest point where you would like to draw a picture, because it gives you an idea. Okay, so let's say right here in the middle, this is Richmond. Okay, so we know car number 1 is going, well, we'll call this way north. Doesn't really matter on paper. And we'll say this is car number 2. Okay, so if car number 1 is traveling, was it 56 miles per hour, remember that's your rate. So if you see miles per hour, feet per second, anything like that, that's your rate. Car 2 is traveling 47 miles per hour. Okay, so what we want to know is, after the end of all of that traveling, when will they be 206 miles apart? Okay. So we know for that distance equals rate times time. So for this to be true, distance will have to equal this rate times some unknown time. We don't know what it is, so we'll just leave it as t. Okay. And this one is going to be 47. So our distance is going to be 47 times some unknown t. Okay. So we don't know how far this one drove north. We don't know how far this one drove south. But at some point, they're going to be 206 miles apart. So that means if we get this distance plus this distance, and we find out when it equals 206, we'll have our time. Okay? So we have the distance of car 1. Plus the distance, oh, let me move that up a little bit. Car 2 equals 206 miles. So that's what we want to know. When those two distances add up together, when will it equal 206? Okay. Does that make sense? All right. Okay. So we know the distance for car number 1 is 56 times t. Okay. So 56 times t plus the distance of car 2 is 47 times t. Equals 206. Okay, so if we add these two together, we'll get that 103 t equals 206. Divide both sides by 103. You get t equals 2. Okay. Like I said, sometimes it helps to draw a picture. Now, this didn't involve a system, but you might see problems like this that will. And we'll cover those in a second. I just want to kind of show you how the story problem setup will go. We'll have one where you have the actual system, and that's when you want to use that same approach to it. Okay? Any questions on that one?